Hello everyone, I am Menaka and I am going to present the procedure of Internet Protocol in Vaishak. First, we will see the content of this video. First, I will demonstrate IP in the OSI model. Second, I will describe about the IP. Third, I will show the communication of IP. Fourth, I will describe the IP data structure. And finally, I will demonstrate the characteristic of IP using Vaishak. Internet protocol is in network layer. The network layer responsible for addressing and routing. The protocol data unit of network layer is packet. The address of network layer is IP address. The network layer responds to requests from the layer above it and issues requests to the layer below it. Internet protocol defines the format of packet and provides an addressing system. It provides addressing host interfaces and encapsulation data into datagrams, including fragmentation and reassembly, and routing datagrams from a source host interface to a destination host interface across one or more IP networks. Next, I will describe about Internet Protocol communication. Transport layer receives packet from the upper layer. Transport layer puts header to the packet based on the protocol like TCP or UDP. After that, transport layer sends packet to the network layer. Network layer adds IP header to the packet which includes source and destination IP address. After that, packet moves to data link layer. Data link layer adds header which includes MAC address of the next hop. Once the packet is received to the physical layer and it forwards the packet to the next hop. Now the packet moves to data link layer and it forward to network layer. Network layer reads source and destination headers based on the routing or forwarding tables and decide what is the next hop. Again, the packet is sent to data link layer and physical layer. Physical layer sends the packet to the next hop. This process continues until the packet reaches its destination. After that, packet moves to network layer, transport layer, transport forward the packet to the upper layer. Internet protocol is very simple and does this only. It does not take care of things like error detection and reliable delivery. This figure shows the IPv version 4 data structure. The IP header is highlighted as shows in figure. Version specifies the IP version of the packet, which will be 4 or 6. Internet header length indicates the length of the datagram header in 32-bit. A minimum length header is 20 octets. Since the maximum value of this field is 15, the IP header can be no longer than 16 octets. Type of service allows an originating host to request different classes of service for packets it transmits. Total length indicates the length of the entire packet, including both header and data. Given the size of this field, the maximum size of an IP packet is 65,535 bytes. Identification used when a packet is fragmented into smaller pieces while transferring through the Internet. This identifier is assigned by the transmitting host so that different fragments arriving at the destination can be associated with each other for reassembly. Flags used for fragmentation and reassembly. The first bit is called the more fragments bit and is used to indicate the last fragment of a packet so that the receiver knows that the packet can be reassembled. The second bit is the don't fragment bit, which suppresses fragmentation. The third bit is unused and always set to 0. Fragment offset indicates the position of this fragment in the original packet. In the first packet of a fragment stream, the offset will be 0. Time to live a value from 0 to 255, which indicate the number of hops that this packet is allowed to take before discarded within the network. Every router that sees this packet will reduce the TTL value by 1. If it gets to 0, the packet will be discarded. Protocol indicates the higher layer protocol contents of the data carried in the packet. Header checksum carries information to ensure that the received IP address is error-free. IP provides an unreliable service and therefore this field only checks the IP header rather than the entire packet. Source address is the IP address of the host sending the packet. Destination address is the IP address of the host intended to receive the packet. Option is a set of options which may be applied to any given packet, such as sender specified source, routing, or security indication. The option list may use up to 40 bytes and will be padded to a word boundary. Let's analyze the Internet Protocol in Wireshark. First, I will open the Wireshark. To capture a traffic, I will use ping plotter. In here, I use Google address to the trace. Sampling number of time to trace will be 3 and I will change the packet size to 56 bytes and I will start the trace. In the background you can see the Wireshark is capturing the traffic. Once it's finished, you can close it and stop the capture. You will select one record. First field is version. So in here the version is 4, which means IP version 4. The second one is internet header length. So in here the header length is 20. Next one is type of service. So in here it says differentiated service field. So next field is total length. The total length is 56. So the header is 20, total length is 56, which means payload is 36. Next field is identification. Here is the identification number. This number is used for the fragmentation to identify each packet. Next field is flags. In here flags is 0, which means there is no fragmentation. Also fragment offset is also 0. The next one is TTL, which means time to live. In here the time to live is 10. After that protocol. In here the protocol is ICMP, which indicates by number 1. After that header checksum. In here the header checksum, this is the value. After that source address. The source address is 192.168.8.103. After that destination address. Here is the destination address 172.217.167.68. Likewise, we can use Wireshark to analyze the characteristics of Internet Protocol. Thank you.